Hello, I'm Breton, one of our MCAT tutors here at Inspira Advantage, where I help students get accepted into med school and other professional programs. One of the toughest concepts on the MCAT involves solving redox reactions in electrolytic and galvanic cells. This is due in a large part to confusion from physics class as well as general chemistry class. I'm going to break the whole subject down for you today into just 3 simple rules you need to know in order to solve any redox problem on the MCAT. The first principle is something you've likely heard before. First principle is known as red cat, or reduction occurs at the cathode. If we know red cat, if we know that the reduction is occurring at the cathode, we then can infer that oxidation is occurring at the anode. But what are the cathode and anode anyway? Cathode just means positive charge loving. So all cations, and it doesn't matter if you're in a galvanic or an electrolytic cells, cations will always go to the cathode and anions will always go to the anode. This is true 100% of the time. Now, the third and final concept you need to know is that galvanic cells proceed spontaneously and electrolytic cells are non-spontaneous and therefore require external energy added and able to work. And when we say something spontaneous, we know that that means they have a negative delta G. Conversely then, a non-spontaneous cell, the electrolytic cell, is going to have a positive delta G. And that's nice and all, but how do we relate delta G to our equation? Well, we have to know a little bit more. So these 3 concepts are what you need conceptually to solve everything, but we need to know a couple equations. And those equations we need to know, the first equation is that delta G equals negative NFE cell. So N is the number of electrons, F is a constant, it's about 96,000, and E cell is something I'm going to dive into in just a second. So I'll put a question mark for that right now. So E cell, this is equal to the E cell is equal to the cathode reduction potential minus the anode reduction potential. And this can be confusing if you don't see it with an example. So let me give you a quick example to put this into practice. So let's say we are given the following information. We have a galvanic cell and the following 2 half reactions. Now we want to figure out what is the anode, what is the cathode, and what is the E cell. Well, how can we do this? Well, since we know it's galvanic, immediately what we want to think is galvanic, it's got to be spontaneous. We have a negative delta G. Okay, and if we have a negative delta G, we must have a positive E cell. Well, how do I know that? I know that because we said that delta G equals negative NFE. So this negative sign causes a flipping between these 2 things here. Okay, so we figured that out. We figured out, just based on them telling us that it's a galvanic cell, that this needs to be spontaneous. Okay, so this is where our second equation comes in. We need to figure out our E cell. And we said E cell is equal to the cathode minus anode. And these are for reduction potentials, which are what are given here. Okay, so can we just look at what is the reducing reagent by just looking at these equations? Could, but it's kind of complicated. So let's make it easy on ourselves, right? The MCAT is timed. You need to go through this quickly. So all I want to figure out how to do is I know that E cell needs to be a positive value. And I know that because we showed it right over here. Just by the nature of it being a galvanic cell and being spontaneous, we know E cell must be positive. All right. Well, how can we do that? We have our numbers right here. We just have to subtract or add them. So what could we do to make this positive? And looking here, actually, this is negative 0.34 volts. So if you saw that, that would be confusing. We've got negative 0.34 volts here. Okay, so how can we arrange these E standard cell potentials to make something positive? Well, my first instinct is let's start with the bigger thing. So let's say we've got, our 0.80 volts, and let's subtract the other one from it. We're subtracting a negative. So that's going to end up being a positive. So we just add that up. And this is clearly going to be a positive value. Specifically, we're going to get a 1.14 volts equals our E cell. So now that we've figured out our E cell, what we need to do to make it positive, we can then back infer which one of these are the cathode and anode. Well, if we're subtracting the anode from the cathode, all we have to do is line these up. So if our 0.8 volts is our cathode, we just need to look back at what was our 0.8 volts. It was our silver. So we know our cathode is our silver. Then our anode must be the thallium here with the negative 0.134 volts, which we showed over here. So we figured out our cathode and anode. We've even figured out our E cell. And this is all we needed to do. Now, something else we can get with this information is if we really wanted to, we could calculate delta G. We could get that delta G value just by plugging in what we know. So if we look here, we see that we have 1 mole of electrons in both of our half reactions. Well, that means when we're plugging in to our NFE, our N is just going to be 1, which is going to be nice and easy. So we're going to just say negative 1 times 96. We're going to round. This is the MCAT. And then again, I'm just going to round our E cell. I'm going to round that to 1. So our delta G is just basically negative 96,000. So this is a really favorable galvanic cell when we set it up like this. You're now well on your way to mastering one of the toughest and high-yield areas of content on the Chem Phys section. The best way to continue building on these foundational principles are to put them into practice. Luckily for you, there's a companion guided example video to get more practice. Additionally, there are great free resources online with examples of practice problems. I'll leave a link to one of these in the description. But if you want even more practice, I strongly recommend using the AAMC resources. There's no better practice than actually practicing with the test materials made by the company you're going to take the MCAT through. Now, I want to thank you for watching our video on the foundations of electrochemistry redox reactions, and I'll see you next time in the guided sample video.